So the only other thing that I wanted to mention before we get going here is, again, the idea, I got your tests graded. They were in the grade book. I think I put them in on Friday. So those are in there. You can see, I would say they were fairly average. I mean, they were decent in terms of the people that, for the most part, were working really hard, have pretty much got A's and B's. Okay, and then some of the people that maybe hadn't been getting some of the homework done struggle a little bit. Obviously, there are exceptions to the rule. There's always exceptions, but if for some reason, remember that you do have the option to do one test this semester of retakes. I'm going to say corrections rather than retakes, where you can go through, come on in, and you'll be able to use like your worksheets and things along those lines to kind of go back over some stuff, and then you actually make test corrections, and you can earn up to half credit back on that. If that's something you want to do, just come and talk to me about it. We'll try to see if we can schedule a time, hopefully this week, if it works out. And then that'll still go on the third quarter grade. Okay. If not, I mean, because of where we're at, I'll kind of let that go into after spring break as well. But it would be better if that's something that you're wanting to do. I would like you to try to see if we can get it figured out this week. Okay. And we'll go from there. So that's, in terms of the test, that's kind of where you're at for that. And like I said, come talk to me if you want to do the test corrections. Otherwise, we do still have, tentatively, we're planning on making sure we get through 2 more chapters yet this year. 2 more chapters during the fourth quarter. So that's also an idea. Okay. Anybody have any questions about the test at all? Okay. Then what I want you to start off with here is, they've got a little warm up kind of right on the top part here on the lesson that I handed out. Go ahead and do the warm-up part, the top part right away if you would, and I'll give you a few minutes. I'll give you 5 minutes to kind of work your way through that, and then we'll start to discuss from there. So for the first question, these were just simplifying, combining like terms. So in part A, as you take a look, one thing hopefully you were careful about, the x minus 2 quantity squared. Remember, you cannot distribute that square. Okay, you cannot square the x squared the 2. You got to make sure you FOIL x minus 2 times another x minus 2 and multiply it all out. If you did that part correctly, here's what you should have come up with. You should have had 4x squared minus 23x plus 23 as your final answer. If you multiply that whole thing out and then just combine your like terms from there. Okay. Anybody have any questions on that one? Anything that you want to go over? My guess is if you made a mistake, the mistake was probably you forgot to take x minus 2 and FOIL it all out and multiply it out. You probably squared each part. Okay. Part B, then you had a couple of distributing and combined like terms. Ultimately, in part B, what you should have had, if you did it correctly then, should have ended up with negative 7x plus 42. Okay, is what you should have had for your final answer there on that one as you simplify them down. Okay, and now part of the reason that's the warm-up is because simplifying these expressions today are going to be kind of the part of the process. You're going to go through and we're going to do some different operations with functions, and then we'll go from there. We'll simplify them at that point. Okay, so as we go through and we take a look, there's kind of 2 main ideas today in particular. Okay, one of them is being able to, and maybe this first one is kind of a third one, if you will. We're going to look at function operations, where here's your functions. What kind of things can I do with them? So number one is, okay, remember that this f of x stuff right here, or f at x, is just another way of explaining y. Okay, f at x means this really is the same thing as y equals x squared minus 2x, or g of x, or h of x, or any of those types of r of x. Doesn't really matter what the variable is, but those all stand for y. Okay, so y equals x squared minus 2x. So when I say f at negative 4, what do I do with that negative 4? Pretty sure what do I do? I think you were doing it. I think I saw you looked at your paper. What did you plug it in? Yeah, you plug it in. It's the value of the function when x equals negative 4. So you take that negative 4 and you plug it in. Okay. So again, keep in mind when you substitute something in, put it in parentheses. Okay. So we have negative 4 squared minus 2 times negative 4. And now we get an answer. Now we evaluate. So negative 4 squared is 16. Negative 2 times negative 4 is a positive 8. And 16 plus 8 gives you an answer then of positive 24 if you go through and do that one. Okay, you get 16 and then a plus 8 when you multiply those, giving you a positive 24. So I said there's kind of three main ideas today. Idea number one is evaluating functions at certain values. Okay, in part B, this one actually turns out to be easier, even though it's kind of more out there a little bit. When it says f at y, what we're talking about on this one is what's the value of the function when x equals y. Here it was when x equals -4, so I plugged it in. Here it's when x equals y, so I'm going to plug y in. Okay, so instead of it now being x squared minus 2x, it just becomes y squared minus 2y. You're substituting that value in. In this case, there's nothing else that we can do. We can't simplify anything else from there, so it's just a substitution. Okay, same idea when you get down to the whole smiley face concept. Okay, we've got the value of the function at whatever smiley face. So same concept. I'm going to take that smiley face and plug it in. Okay, so we have the smiley face squared minus 2 times that smiley face. Okay, that's what we're taking a look at. So once again, the point I want you to get out of this is anytime you're doing f of something, that something is getting substituted into the equation. Whether it's an actual numeric value, whether it's a variable, whether it's a smiley face, it doesn't matter. You're just plugging it in. That's what's going on. Same idea when we do part D here, final concept on this one. If I take that x plus 3 and I substitute it in, we then have x plus 3 squared minus 2 times x plus 3. So every place there was an x in the original problem, we take that out and we substitute in this case, the x plus 3. Okay? So, and again, make sure you put it in parentheses. And now here's why we did that, those first two questions with the warm-up where we said, now let's go through and simplify as much as we can. Because that's exactly what we're doing now at this point. We've substituted in. Now I want to simplify this down as much as I can. So now this becomes like those first problems of the warm-up. Okay? So if we take a look again, x plus 3 squared, again, I cannot distribute that. Instead, we got to multiply it out. So when I multiply this out, I get x squared plus 6x plus 9. That would be x plus 3 times x plus 3. And then I'm going to take this -2 and distribute, meaning we've got a -2x, and then we would have a -6. And now the only thing left to do is combine like terms. Put everything back together. So we get x squared, positive 6x minus 2x gives me a plus 4x. Positive 9 minus 6 gives me a plus 3. And that's as far as you can simplify on that one. As far as we can go. Okay, so concept number one is finding the different values, just substituting into your equation and then being able to simplify what's there. Okay, that part makes sense at least? Get the idea? Hopefully that's fairly straightforward. Substitute in and then simplify what's left. All right, so then if you take a look down below at that where the table is towards the bottom of the page. So this is kind of main idea number 2. Okay, and this is probably the main idea of today, and then we've got a secondary one. But this is now, what do I do with functions? How do I take care of, how do I add functions together? Subtract them, multiply, divide. We're going to do kind of the 4 basic operations of functions. And so if we take a look, get rid of this stuff. Get rid of that. And if we take a look in the example that they give you in that table, okay, they tell you that f at x is 5x and g at x is x plus 2. And so there's our 2 functions. And what we want to do are kind of the 4 basic operations. So I'm going to take, and they're calling their new function h at x. Okay, that's what when they look in the definition column, that's what they're saying. is h at x is going to represent f of x plus g of x first. So I'm going to call that kind of part A. That's the first row. So if I'm going to go through and add these two functions together, that means h at x would be 5x plus bx plus 2. Okay, those two quantities. And anytime, this one you've already done, this should be nothing surprised here. This should just be combining like terms. That's all this is. When you add functions together, you combine like terms. So that 5x and that x we can put together. We get 6x. That plus 2, there's nothing else to go with it, so we just bring that along. And there's your answer to the end of that row on that, okay, where it says equals at the very end. H at x in this case would be 6x plus 2, if you put those two functions together. So adding, you're just combining like terms, okay? Matter of fact, same exact idea when we're subtracting, with one extra thing that we have to consider. If I subtract the two functions, still the same idea, that again, I once again have to go through and combine like terms. But what do I have to be careful of on this one, so that I don't forget? One thing you got to be careful of, that people would make a mistake. What do you think, Vitro?
X plus 2 is going to be like negative.
Yeah, you got to take that. You're subtracting this whole quantity, not just subtracting the x, so you got to distribute that x, okay? So we'll take 5x minus x, giving me 4x, but then if I distribute the negative, this becomes a minus 2 instead of a plus 2, okay? So just be careful that when you subtract a quantity, you got to distribute the negative, okay? You're subtracting the whole thing. Yeah, Kaylee?
Where are we?
In the table, the second row, subtraction row. Right here. Okay, so adding and subtracting, like I said, combining like terms, that's pretty much what you're doing. Just be careful when you're subtracting that you subtract the entire quantity, not just the first term. All right, then we go to part C. We go to the next portion here. Okay, h at x. What we're doing. H at x in this one, when we multiply these two functions together, if I take this first one, 5x, and I'm going to multiply it by the second one, x plus 2. This one's right back to kind of like what you were doing in the warm-up again. You're just going to distribute. Take the 5x, distribute that into the parentheses, okay, and get an answer and simplify from there. So 5x times x gives you 5x squared. 5x times 2 gives you a total of 10x. In that case, once again, there's no simplifying we can do because they're not like terms, so we leave that alone. So far, I'm hoping you're looking at this and saying, like, all right, this isn't anything new. We've known all of this stuff. That's what I'm hoping for, because that is a true statement. Then if we take a look at the last part, the last part's actually probably the easiest one to put together, but then it adds one thing we got to consider on this one. Okay, so h at x on the last part, when we talk about division, in this case, it's just going to be f of x divided by g of x. So that means f of x is going to go on top. G of x will go on the bottom. And here's the one extra thing when you're dividing that you got to keep in mind. Because we just created a fraction, what can you not have in a fraction? What can you not have? What can you not, and I'll go even a little step further, what can you not divide by? What do you think? What can I not divide by here? Last, what do you think? Help me out.
Variables?
You can have variables in there. That part's okay. Think back to like grade school. This is going way back to the basics. What can you not divide by? Ever. 0. There you go. I can't take something and divide it into 0 parts. If you start with something, you're going to have something, okay? So we can't divide by 0. So here's what I need to add to this one. So this is the fraction. However, we have to kind of limit the domain a little bit. Remember back to domain and range? We talked a little bit about that previously. Domain is what x, basically what x can or cannot equal, okay? So in this case, I cannot have 0 in the denominator. It's not allowed. We can't divide by 0, which means what can x not equal? X cannot equal what value? Not 0. Because if I plugged in 0, I'd get 2 in the denominator. I can have that.
-2.
-2. If I plug in -2, that's the value of x that would give me 0 in the denominator. So we have to add that part of our restricted domain to that problem, okay? Here's the division. There's nothing I can do here, okay? It just is what it is. It's one function over the other. But then I have to make sure that the domain gets restricted because I can't have 0 in the denominator. So x cannot equal -2. So there's your 4 operations that we're talking about with functions. The first 3, like I said, I'm hoping are pretty straightforward. The only extra one that you have on the 4th one is just that idea that we then have to restrict the domain so that the denominator does not equal 0. Okay? Let's go to the back side real quickly. Let's take a look at the top of the next page. And I'm going to kind of skip to parts B and C, okay? Rather than go through and subtract the functions, I'm going to skip right to the dividing part. So if you notice, when they say V of S over P of S, okay, we're going to put the V of S function on top. We're going to put the P of S function on the bottom. So that means we've got S plus 3 over the quantity S minus 4 times the quantity S plus 3. Okay, so there's our function written out, which we can simplify. Okay, it does simplify down, although before we simplify, I want to restrict that domain. So in this case, what can S not equal? What can S not equal on this one? What do you think? Simon, what do you think? What values can S? There's 2 values that S cannot be equal to. -3 is one of them. Haley, what's the other one?
+4.
+4, yep. Because if S equals -3, you'll get 0 here, and therefore 0 in the whole denominator. It's kind of like the zero product property is basically the idea. Okay? If you're going back, what values would this equal? What values of S would make that equal to 0? Well, those are the ones you can't have because you don't want it to equal 0. Okay? So there's our restricted domain. I did tell you that we could go one step further. We could simplify this because if you think about this as a whole quantity, notice there's an S plus 3 in both numerator and denominator, which means those I can cancel out completely, those whole factors. I can't cancel out terms, but I can cancel out factors. What's left in the numerator then? What is that, guys? 1. Okay? We've got 1 in the numerator, and then we've got the S minus 4. There would be the simplified version of your function. Okay? But before you simplify it, you got to make sure you restrict that domain before we get to that. Okay? How are we doing on those? Make some sense, hopefully? Okay? That's the adding, subtracting, multiplying, dividing. There's one more concept that I want to get to here that I want to cover today. All right, so if you take a look at the next page then, okay, flip that packet over to the next page. And so if you notice at the top, it says another operation you can perform with functions is called A. In that blank, it's composition is what you're putting in there, okay? Is a composition. This is when we use a function as the input of another. So this is going to kind of go back and kind of combine the 2 things we've talked about already. So if you look at the examples in the next block here, we've got f at x equal to x plus 2, g at x equal to x squared plus 6. Okay, so there's your 2 functions. And a composition is kind of like when we did f at -4, we said, well, let's take the -4 and plug it in. The difference is we're gonna take one function and plug it into the other. Okay, so we're gonna substitute, but we're gonna take the whole function and plug it into the other one. So for part A, for example, they've got f at g at x. Okay, so this is one way of writing this composition. This is a function inside of a function. Here's what this means. We're going to take the g of x function, okay, the x squared plus 6, and we're going to plug it in to the f of x function. You always take the inside one and plug it into the outside one. So really what I'm doing is I'm doing f of x squared plus 6. Taking the g of x function, I'm going to substitute it in. So this is just like that last warm-up problem where it was f of x plus 3. And we took x plus 3 and we plugged it in. Same exact idea. I'm going to take this whole function, the x plus 6, and I'm going to substitute it in place of the x in the other equation. It's a function getting plugged into the other function. So we take the x out, and we put the x squared plus 6 in its place. So we would have x squared plus 6, and then we still have the plus 2 at the end. Okay. Pull the x out, put the other function in. And now from here, we're right back to, let's simplify this down again as much as we can. I've got a positive 6 and a positive 8, or a positive 2, excuse me, to get positive 8. So my final answer would be x plus 8, x squared plus 8. So we take one function and plug it into the other. The inside function goes in. Let me stop for a second. Any questions on that? Because I know that gets a little bit confusing.
I thought because it's in parentheses, you can't touch the 6.
In this case, I put it in parentheses just to show that I was substituting it in for the x. But in this case, I don't really need the parentheses. I only put them there just to show you that that was substituted in. Okay. Any other questions? Anything else we need to clear up before we move on at all? All right, so then let's take a look at part B. If we take a look at part B, it's written a little bit differently. They write it this way. Okay, now the first thing is to understand what that actually says. This is not a times sign, I'll tell you that. Okay, it's not a multiplication sign. So this is not g times f of x. This is g of f of x. So another way of writing this exact same thing would basically be to flip-flop this one. You'd have g on the outside, f at x on the inside. And these mean the same thing, it's just two different ways of writing it. Which means, what are we going to do on this one? We're going to take the f of x function and plug that in to the g of x function. Okay? So what I'm really finding is g of x plus 2. So we're going to take x plus 2 and plug it in. So if we do that, we've got x plus 2 squared, and then you still have the plus 6 at the end. And then once again, from here, we try to simplify it all down as much as we can. Remember again, cannot square a binomial, cannot distribute. Okay, you got to multiply it out, x plus 2 times x plus 2. So if we do that, you get x squared plus 4x plus 4. And then you still have that plus 6 at the end. And now we just combine like terms. How are we doing there? Making sense in general? The basic idea is you're taking one function and just plug it into the other. That's the basic idea. Now, if we throw some numbers in, it actually turns out that when you have numbers, it's a little bit easier. So in part C here, they have f of g of 3, which again, I'm going to rewrite it just so you can see it a little bit different way. It's the same thing as what we had here in part A, except instead of an x, we've got a 3. So this is really the same thing as f of g of 3. And as always, we start on the inside and work our way up. So the first thing I'm going to find here is g at 3. Okay? So if I take 3 and I plug it into the g of x equation, 3 squared gives you 9. 9 plus 6 gives you 15. So what I'm really finding, f 15. Got an answer from taking 3 and plugging it in for g of x. And now I'm going to take that answer and substitute it into f of x. If I plug 15 in here, 15 plus 2 gives me an answer of 17. Like I said, it's a little bit easier because you've got some numbers involved where you're actually getting answers rather than doing a bunch of algebra. And the only difference on part D, if you take a look at part D, is that you're doing the f of x equation first. You're going to find f at 3 first, then take that answer and plug it into the g of x equation. What I would like you to do is try the ones where it says you try down at the bottom. Try those 4 fairly quick, or those 3, excuse me, fairly quickly. See what you come up with. Because I want you to be able to try this and make sure you're understanding before we go any further. So give that a shot. All right, let's see how you did here. And if you did not get something right and you can't figure out why, please ask. Okay, that's kind of why I had you do these 3, is because I want you to make sure you're able to do what you need to be. So for part A, you should have come up with 98 as a final answer. You do f of 5 first. Okay, when you plug that in, you should get 7 as an answer. And then you take that 7 and plug it into your g of x equation. Remember to follow order of operations. Okay, so when you plug that 7 in, make sure you do the squaring first before you do the multiplying by the 2. Okay, so make sure you follow that. So you should get 98 for part A. For part B, you should get an answer of 142. You did that one correctly. You take 5, plug it in for g of x. In that case, when you do that, you get 50. And then that 50, plug it into f of x, and that's where the 142 comes from. And then the last one, if you take a look, the g of f of x, you're taking the f of x equation and you're substituting it into the g of x equation. Okay, so f of x is going into g of x. So in this case, if you do that, that means you're going to square the 3x minus 8. And again, you'll have to FOIL that out. And then once you do, then you multiply by the 2 that's in front. Okay. If you did everything right on that one, you should end up with an answer of 18x squared minus 96x plus 128 should be your final answer on that one. Taking the 3x minus 8 and substituting it into the g of x equation. And then everything else from there is simplifying it down.
After you 3x minus 8, after you simplify that,
Yep.
then do you multiply it by 2?
Yep. So you'll take the 3x minus 8, you'll square it out, you'll FOIL it out. If you do that, you should get 9x squared minus 48x plus 64. Then you've got the 2 that's in front, but then you got to just double everything. Okay. So you square the 3x minus 8 first, then you do the multiplying by 2. Okay, so like I said, 3 main ideas today. Number 1 was just the f of x, just substituting stuff in. Number 2 then were the different operations, and what do I do? How do I add, subtract, multiply, divide functions? And then number 3, this idea of a composite function where you take a function and put it into another function, okay? So I'm gonna give you the worksheet for today. The worksheet that I give you today is the last assignment that is going in the grade book for this quarter. Okay, so this will be due by Thursday at midnight. Okay, and in this case, I'm not gonna take any late work on this one because of the fact that my grades are due on Friday. So this one is due by Thursday at midnight. And on Friday morning, then if it's not turned in, I'm gonna put NEs in it and we're gonna move forward. So this one shouldn't actually take you very long either, I don't think. So here is that worksheet. Answer key again, as always, is out on Canvas, so you can double check, make sure you've got the answers down correctly.
Really, like it here.
Oh, thanks. I hate it.
Why?
I'm trying to make it pink. So I'm